Hello class, welcome to this video on 6.1, 6.2. We're going to go over the practice problems from the practice quiz. So let's go ahead and get started. So for the first question, this is a 6.1 type question where you have to add the interior angles in a polygon. So here we have what looks like a pentagon because of the 5 sides. So we know that for this pentagon, and it's a convex pentagon, which means that n equals 5, and we can use the rule for convex polygons for the total of the interior angles. So you can say that to get the total of the interior angles, you would take the number of sides, take away 2, multiply by 180, and so in this case we have 5 sides minus 2 times 180, and so for a pentagon, the total of the interior angles is 540 degrees, which means if I add up all these angles, I'm going to get 540. So we can set up the equation accordingly, and we have 2x plus 15 plus 3x plus 10, or minus 10, plus 3x minus 8, plus 5x minus 2, plus 3x plus 1 equals 540. All right, so we added up all the angles on the left side and we set it equal to the total of 540 on the right side. We're going to go ahead and combine like terms here. So I'm going to combine the two x's together. We have 2x plus 3x is 5x, plus 3x is 8x, plus 5x is 13x, plus 3x is 16x. Then combining the constants together, you have 15 minus 10 is 5. 5 minus 8 is negative 3. Negative 3 minus 2 is negative 5. Negative 5 plus 1 is negative 4. It's equal to 540. We can go ahead and solve the equation by adding 4 on both sides. Bringing this down, we get 16x equals 544. And then we'll top it off. We'll divide off by 16 on both sides, and we're going to get 34. So if you divide those two. So x is 34. Now if I want to figure out angle r, well, I simply have to plug this in to the angle for angle r. So the measure of angle r, we'll do it over here, is equal to 3x minus 10. So it's 3 times what we got here, 34, and then minus 10. So 3 times 34, that's 112, or that should be 102 minus 10. And so we get that the angle R is 92. All right, that takes care of question 1. That's a 6.1 type question. And question 2, another 6.1 type question, find the measures of an interior angle and an exterior angle of a regular 24gon. So we got a polygon that has 24 sides, so we know that automatically n is 24. And it says find the measures of a interior angle. So we're looking for one interior angle. So what we do is we use the formula that we had earlier for interior angles, but then we have to take this total and divide it by how many sides we have in the polygon, and that'll give us the measure of the angle for each of the angles, okay, by dividing by the total by the number of sides. So that's the measure of one of the angles. And so for a 24gon, we have 24 minus 2 times 180. That's the total divided by the 24 sides, or the 24 angles. And we get how much each angle is worth. So we have here, and we'll do this on the calculator, we have 23 times 180 is 4140. Divide that by 24. And leaves us with 172.5 for a 24. Oh, I made a mistake on here. This would be 22 times 180. So let's change that number. It's 3960. then divide by 24. And that gives us a nice whole number of 165. So each of the angles in a 24-sided polygon measure 165 degrees. All right, so let's see here. The measure of an exterior angle is how many degrees? So in an exterior angle, if you were to add up the exterior angles in any polygon, say in this case a hexagon, you were to take all the exterior angles and add them. So here, 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 and so on. You take all those and add them, you're going to get 360. So the sum of the exterior angles is 360. And so we're going to get 360 divided by how many sides we have, and that'll tell us how much each of the angles are worth, okay? Rather than the total. So then we're going to do, in this case, we'll do 360 divided by 24-sided polygon. And that's going to be 15 degrees. So that's saying that each of these exterior angles is 15 degrees for a 24-sided polygon. All right, next question. We got another angle type question. So we know this is probably going to be a 6.1 level type question with a polygon and an exterior angle. So we got some interior angles and we got an exterior angle. So we want to find the value of y and z. Now, since this is a quadrilateral, it has 4 sides. If we look at the formula for the interior angles, remember that it's n minus 2 times 180 for a convex polygon. And so we have 4 sides in this quadrilateral. And if you did that, you get 360. So we know that the angles add up to 360. So all 4 of these angles must add up to 360. However, we do have 2 unknowns, so we're not able to solve this yet. So what we're going to do is we're going to get z first, and then we can get y. The reason we can get z is because we have an exterior angle here. We know that this is 105. And if I take 105 and I take z, they should add up to half a circle. You can see the drawing that I made there. And remember that a full circle is 360 and half a circle is 180. So this is a linear pair. These are supplementary angles. So they have to add up to 180. So I can use that to find z. So z plus 105 equals 180. And then I can subtract 105. And that leaves me with z is 75. So we got z right off the bat. So this is my z. And next I'm going to get y by adding up all these angles. So we have here y plus 99 plus 84 plus 75. And that should equal 360. So then we'll add these angles together. So we got 99 plus 84. That's going to be 183. And then 183 plus that is 258. I'll double check these numbers just to be on the safe side rather than relying on my mental math here. That's correct. And then we'll subtract 258 on both sides. Okay, so that's going to be 102. That's what it looks to be. All right, so y is equal to 102 degrees. All right, for question 4, we have a trapezoid. So this is going into 6.2 stuff. Some of these are kind of mixed. So number 5 is a 6.1 question. So they're not necessarily in a specific order. But this one is a 6.2 question. 6.2, remember, deals with trapezoids and kites and properties for those. So for question 4, we're looking at a trapezoid, an isosceles trapezoid. We know this is isosceles because these two opposite sides are the same. The two non-parallel sides have the same measure. And because of that, because it's isosceles, then we know that the distance here from M to P is the same as the distance here from N to Q. That's important to know, is that those distances are the same. So we know that PM is equal to QN. All right, so we'll just indicate that here, that the entire length is the same, not just this little chunk, the whole thing. So because we know, so it says MP is 3x minus 5. I guess we can call this MP instead of PM. It doesn't really matter, but I want to be consistent with the problem. So, and then it says QR is 2x plus 8. So QR is this part. So this is 2x plus 8. MP, this whole thing, 3x minus 5. And we have Rn is 3. I'll go ahead and I'll use another color for that. And in fact, I'll use another color for 3x minus 5, just so that we're not confusing ourselves. Okay, so we got those numbers here, or variables, or expressions. And what we want to do is find Qn. So Qn is, well, it's this whole thing. That's Qn. Okay, so, but we know that Qn is the sum of 2x plus 8 and 3. So if we add the purple and the red, that gives us Qn, right? So we're going to say, okay, well, Qn is 2x plus 8, and it's plus 3. Okay, that makes sense. And then MP, we said that MP is the green, right? So they should be equal to each other. So we're going to go ahead and plug that in. They have to be equal to each other according to this, because we said the diagonals have to be the same measure. So if I put the 2 for the yellow one together, I should get the green one. And that's my equation. And then I go ahead and solve that. So we have 3x minus 5 equals 2x plus 11. We'll combine the terms there. Then we'll subtract the 2x just to move it to the left side. 3x minus 2x is 1x minus 5. Bring this down. Don't forget to bring down the minus. Bring down the 11, and then we'll add 5 to both sides. All right, so we got x. So we're looking for Qn. So we're looking for the yellow. But we know Qn is all of this. So we're going to plug it in to that, okay? So we have, so let's plug in here. So we have 2 times 16 plus 8 plus 3. We know 8 plus 3 is 11, so I'm just going to change that to an 11 real quick just to make it easier. And this will be Qn. So 2 times 16 is 32. 32 plus 11 is 43. All right, that takes care of that question. Next question is a 6.1 question, angles. If each interior angle of a regular polygon measures 108, how many sides does a polygon have? So if we're looking at each of the angles, then we're looking at the interior angles, and this is assuming that it's a convex. It doesn't really specify, but we're assuming that it's a convex polygon, so that we can use the formula, n minus 2, take away 180. And that's for the total angles. If I want to do each of the angles, I have to divide by how many sides we have. Okay, and that's my formula. And it says that each of the angles is 108. All right, and that's my equation. I'm going to go ahead and solve that equation. Now, if I want to solve it, what I'm going to do is I'm going to get rid of this n on the bottom. And right now it's being divided. So I need to multiply it to cancel it out. So now n divided by n is 1, and it goes away. And then whatever I do on one side, make sure to do on the other. So now we have this equation. So I'll rewrite that. And remember, when you have a number multiplying on the outside of an expression, you need to use the distributive property. So we have 180 times n minus 180 times 2, which is 360, equals 108 times n. We'll go ahead and we're going to move the n's to the right-hand side because it saves us an extra step. because we already got all the ends on the one side here. So we'll combine them, bring this down. We got minus 360 equals, we'll subtract these two, that's negative 72n. And then we'll divide off by negative 72 and see how many sides we have here. So we're going to do 360 divided by 72. And looks like it's going to be 5. So n equals 5. So that means we're looking at a pentagon with 5 sides. All right, question number 6. This is a 6.2 question. It has to deal with kites. It says, given the kite ABCD in which AN equals 2.6, what is AC? So we know for a kite, we have two diagonals. We have a minor diagonal, we have a major diagonal, right? So this minor diagonal, remember, is congruent when it crosses with the major diagonal, it cuts it in half. So that's 2.6, and we know that this has to be 2.6. Okay, so that's a property of the kite. And it says, well, and that's all we're looking for, right? So because we know that this is 2.6, then this is an easy problem. We want to find AC. So AC is just 2.6 plus 2.6. That's it. So you just got to add those together. It is 5.2. Very, very simple. All right, question 7, find the missing angle measure. This is a 6.1 type question. We're looking at a 2, 3, 4, 5, 6 sides, which is a hexagon. So we need to figure out, well, it says we're trying to find the missing interior angle. So we're going to get the total of the interior angles. Remember, it's that formula, n minus 2 times 180. So we have 6 sides here. So we got 4 times 180, which is 720. So we got 720 degrees should be the total of these angles. So let's add up all the angles, make our way around here. So x plus 146, we'll do it down here just so we have enough room, plus 167, plus 53, plus 133, plus 125. And that's supposed to equal 720. Go ahead and add these numbers together, of course, and we'll do this on the calculator just to speed up the time here. And that's going to be 624. So we got x plus 624 equals 720. We'll go ahead and subtract 624 on both sides now. And that's going to be 96. All right, so let's see, so that is x, and it turns out that the missing angle is x, so that's it, that's our answer. So our answer here is x equals 96. All right, question number 8. Find the measures of the numbered angles in the isosceles trapezoid. So this is a trapezoid, so this is a 6.2 problem. So it says find the measures of 3 and 2, essentially. We know that because it's a trapezoid that these are parallel, okay? We call those the bases. And we're also trying to find angle 1. So we're trying to find a base angle as well. All right, so just type a number for the angles below. So we have, okay, so 1, 2, and 3. Okay, so if I wanted to find these angles, well, a couple of things you need to know about trapezoids or isosceles trapezoids. Well, if these are congruent, then that means these base angles here are also congruent. Similar to a trapezoid or an isosceles triangle. An isosceles triangle has 2 of those sides the same, and we know that these angles are congruent. Same deal with the isosceles trapezoid. Since it's symmetrical, it's symmetric, right, here. That means that 52 is equal to angle 1. So angle 1 is 52 degrees. Also, remember for a trapezoid that because these are parallel lines, I can think of this as a parallel line transversal problem. And notice that these two angles here are same side interior. And because they're same side interior, they had to add up to 180. Okay, so the idea is that to get angle 3, you simply have to add it to 52 to get 180. Okay, so we know that the measure of angle 3 plus 52 degrees has to be 180. They're supplementary. And that works for a trapezoid, as well as some other shapes. So we have here 128. So this is actually 128 degrees. And because it is isosceles, it's going to be the same as this as well. All right, so we got 128, 128. All right, question 9, a kite. So 6.2 question, find the measures of the numbered angles in the kite. So we know this angle is 32. Now, here's the thing that we need to know for a kite, a couple of things here, even though this is not part of the question. When we know that these have to be congruent, okay, cuts it in half, we also know that this has to be a right angle. The minor and major diagonals in a kite form a right angle. They're actually perpendicular to each other. And then we obviously know that since this kite is symmetric, these are the same distances here, or yes, they're congruent. And so then let's go ahead and find the angles. Because this is a right triangle, we should be able to find, the angles here. So angle 1. Another thing you need to know is that if this is 32 degrees here, then this is 32 degrees as well. So this is actually this major diagonal here is actually an angle bisector. Okay, so we know that that's 32, so then we can go ahead and find the other angles. So we obviously know angle 1 is 90 degrees because we said that that's one of the properties. So angle 1 is 90. Okay, so we'll put a little right angle there for angle 1. And because this is a right angle, then this is a right angle as well. And because this is a triangle, I can find angle 2 because the angles in a triangle add up to 180. Okay, so this is my triangle here. This is 32. This is a 90-degree angle. I can find that missing angle. We'll call it x. And so x plus 32 plus 90 degrees is 180 for a triangle. And you can use a formula for the triangle, 3 minus 2 times 180, and you'll get 180. Or you could just know that from the triangle angle sum theorem that it's 180. So if x plus 122 equals 180, we'll subtract 122 on both sides, leaving us with x equals 58 degrees. So now we know this is 58 degrees. And because that's 58 degrees, that also means that this is 58 degrees as well. Those two triangles are congruent by, in this case, side, 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 or there's a lot of things that you can classify this, but we know that all the sides are the same. Reflexive property here, this side and this side are the same. There's a lot of cool things that you can get from the properties of these quadrilaterals, and it ties in closely with what we talked about in previous chapters. But anywho, we're moving on to the next question. We have a trapezoid, and this is another 6.2 problem. So it says find EF in the trapezoid. So this is a midsegment theorem. Okay, so we have a trapezoid, and you have what we call a midsegment. Okay, so this midsegment is basically halfway between these two bases. Okay, so between this base and between this base. And if it's halfway between them, we call it a midsegment. And to find the midsegment, you just have to take the average of the bases. So the bases here are 5, 9x plus 3. Okay, and then we'll just write this as a formula so that we have it. So in order to get the length of the midsegment, we take the average of the bases. Okay, so the base A, or the midsegment rather, is 4x plus 7 equals, we have 5 plus c. C is 9x plus 3. Divide that by 2. And we can solve this equation to get x and then to get the mid-segment. So we're going to get rid of this 2. Right now this 2 is being divided, so I am going to multiply it to cancel it out. Remember to do the same thing on the other side. But since this is an expression with a plus in between, we need to, it's a binomial, we need to put a parentheses around it so that we remember to distribute. So we have 2 times 4x is 8x, 2 times 7 is 14. Now we're left with 5 plus 9x plus 3. Remember to combine your like terms here. So we have 8 plus 9x. Now I want to get a positive value for x, so I'm going to subtract x and move it on the right hand side, and that'll ensure that my x stays positive, 9 minus 8 being 1. And then make sure you bring down the rest of your numbers and the equal sign. Now we know that x is 6 because if I subtract 8, I will get 6. Okay, so now that we got x, we can plug it in. Plug that in here, and that will give us a. Okay, so a, you just do it over here, is 4 times x, which we said was 6, plus 7. 24 plus 7 is 31. So a is 31. And that's EF. All right, question 11. We have another mid-segment theorem, a trapezoid mid-segment theorem. So we're trying to find this this mid-segment, and we know the bases. So we know that this base is 12, the right side. We know that the left base, we do know the left base because it's 2.5 times this, right? And we know that that's 12, so we can plug in 12 in there. So if we do that, we got 2.5 times 12. And the way I do this is 2 times 12 is 24, and then half of 12 is 6, so 24 plus 6 is 30. So we know that this is 30, that whole, this whole side, GF. So we can take the average, and that'll give us HL. Okay, so remember, if we want to get A, we got to average the bases, in this case B and C. Okay, so the formula was A equals B plus C divided by 2. Okay, so we got A equals B is 12, C is 30, divide that by 2. And you get 42 divided by 2. So A is 21. So HL, which is in this case the length, A is 21. All right, that's going to do it for the video, guys. I hope you found this useful. And as usual, I'll see you in the next one.